Hi, welcome to ToddFun.com. I'm Todd Harrison, and this is where I share whatever I think is fun to do, interesting, or helpful for others. What I'm going to go over today is a new bit of gear I got from my bench, how useful it is, how to use it, how to test it and use it properly to keep you safe and to keep your equipment safe, specifically your oscilloscope. What it is an isolation transformer. The point of an isolation transformer is, in a tech environment, is to isolate you from a high voltage ground reference environment. So in America, we live in homes and labs and in workshops where a high voltage comes into your home and is referenced to ground. Any point of ground, pretty much, physical ground, and anything, especially anything that's wired to your grounding system of your home is a very good ground point, which if you get between those potentials, you or your equipment, because you're working on equipment or because there's a fault, it could cause damage to you or your equipment. So with an isolation transformer, it decouples those two systems, so you have a primary and a secondary on that transformer, and the primary is your house power and the secondary is what you'll plug in your test gear, circuit under test. And they're decoupled, large voltages or lightning strikes and noise to some extent, it can't get across that gap. So that protects your equipment from those events. And provided you have a tech version of an isolation transformer, you're also isolated from producing a loop from the high voltage to ground. Now I specifically say a tech version of an isolation transformer because if you get a public version of an isolation transformer, they're only worried about just the decoupling and the noise canceling, so that monitoring equipment like at hospitals or for computers or in labs is protected from that noise and from those potential high voltage spikes. They're not so worried about a high voltage ground reference fault. So that doesn't mean you can't get a public version of an isolation transformer, but if you do, you have to alter it so that it actually will work for you, so that you can be protected when you're working on a power system. You are protected from a high voltage ground reference environment, and so is your test gear. So current will always flow to loop. So if the ground is a point on the circuit and you become a point between the high voltage and any type of ground, then you could get hurt. But with an isolation transformer, the primaries on this side, the secondaries on this side, the current will only flow through the secondary loop, and hence if you touch any part of the secondary and your feet are on ground, ground is no longer a reference point to this secondary side of the transformer. So you can't be in the circuit, nor can your oscilloscope or any other piece of gear. For a tech bench, that's true. But when you buy one of these publicly available isolation transformers like a Tripp Lite, they actually tie the secondary coils to ground. They do that for noise canceling, for common mode noise canceling for the sensitive equipment. That's no good for you as a technician, because now the secondary is also on the ground plane with everything else. So if you become a short between your circuit under test and any ground, you're still hurt, and so is your equipment. What you need to do to change that, though, is when you buy one of these public available isolation transformers, one which actually is rated for the amperage you need and you want, you have to alter it so that it doesn't do that anymore. And it's as simple as opening it up and taking off a little grounding strap that they put in there that straps that secondary. That thing weighs 40 pounds, by the way. straps that secondary transformer coil to ground. By taking it out of the circuit, and I'll show how to do that later, I'll even show the dangerous voltages that are there in a standard public isolation transformer with some tests here coming up. And then I'll show that after we alter the isolation transformer, it becomes a isolation transformer tech version of an isolation transformer. So outside of the safety factor for you becoming a potential short to ground, which would hurt you, the concept of having this on a tech bench is because you have a very expensive piece of test gear called an oscilloscope. And one of the biggest gotchas on these when working with high voltage mains power is that you want to hook up, and you can hook up this scope to mains power, but if you do it wrong, you're going to fry this product. Specifically, the reason for that is these BNC shrouds is the grounding point for your probe. It's also a part of the chassis, and the chassis goes to ground, goes to earth mains ground. So you can imagine that if you hook up your probe, a single probe to your circuit under test, and you hook this little grounding clip up to something that's not actually earth mains ground, something that's going positive and negative on somewhere in your circuit, well then this is a dead short to ground through that BNC connector on your scope, which for this chassis, directly to its little plug, this little third prong. If you don't believe me sometime, measure continuity between those points and you'll see it goes straight through. So of course you can't hook up something that has high voltage straight through the ground. It's going to destroy stuff. It's going to make a little mini welder out of your oscilloscope. So there's the main point for an isolation transformer. As long as you alter it so that it's a tech version of an isolation transformer, there's no longer a reference to ground. You can still power, you can still take your isolation transformer, which is a 1-for-1 transformer, going 120 volts to 120 volts, and you can still power your circuit under test, provided you don't have that secondary strap to ground. And you can hook up your probe to different parts of that circuit, even high voltages, and we'll show that here. We'll demonstrate that here in a minute. That's okay though, because then the probe is going to say, well, what's the difference between the voltages between these 2 points? But they can't get to ground anymore because the isolation transformer isn't providing an earth mains reference ground, and hence your oscilloscope can't make that connection either because it's not there. So you're safe, and your equipment is safe, and that's what we're really after. Now, 2 other safety gotchas that I really got to make sure I mention is when you are using a tech version of an isolation transformer, and you're safe using that as oscilloscope, first oscilloscope probe, you're not safe once you hook up that oscilloscope. And that's because this grounding clip on your probe goes to your oscilloscope, which goes to ground. You just strapped your secondary of your transformer to ground again. Okay, which is fine for one probe because it can't pull anything. You can't pull any current to ground that way. But you've just set up that scenario again. So now, if you touch any point on your circuit that's at a higher potential than what you just clipped onto with your grounding clip, you now can become a high voltage ground reference circuit again and hurt yourself. So you've got to be ready for that gotcha, because when you hook this up, you're basically creating, wherever you hook this up on your circuit, doesn't really matter, wherever you hook it up, this becomes the new neutral reference of your secondary on your transformer. And hence any other point is either higher or lower from reference to this and reference to ground through your scope. Now you might be able to get a certain type of equipment for your scope, so your scope has a ground monitor or some other safety equipment, but you got to keep your head in the game no matter what you're doing, and so I just want you to be aware of that little scenario. And here's another one. It gets a little tricky. If you got your second probe, and like I just said, you hook up this one, and you just made that new neutral reference on your secondary to earth mains ground. The other probe is hooked up to ground too. If you got another probe, you want to probe another spot, you hook this up to the same exact spot of this, and you're fine, because they're at the same potential. But if you decide to hook this second probe, which has a grounding clip to ground, to some other potential on your board, you switch it by accident, and you put this grounding clip at a high voltage reference on your board, you just grounded out your secondary of your transformer, your isolation transformer's secondary windings just got grounded out through your scope. And that's going to damage your scope and your other equipment. It's going to make a dead short on that secondary. So you get out a second probe, be careful. Don't be just make sure you put this in the same exact point as you put the other probe, and watch yourself, because you've made your circuit dangerous. In fact, I'll throw that up on a whiteboard here, and I'll also demonstrate that at the end, so you have a clear understanding that you've set your circuit up to be dangerous again. But just use one probe, and you'll be okay. Well, once you got the probe hooked up, you're not okay. You're in danger again. So be safe again. Watch where you're touching. Now, if you don't have an isolation transformer, a tech version of an isolation transformer, you can do the old way, which is basically just a two probe system. What I do, and I think I've covered this in older posts, is I just take off these ground clips off of my two probes. Technically, you can just leave them and hook them together, which would actually reduce the inductive pickup of your probes. But with a two probe system, you then can hook up, without an isolation transformer, you can hook up this to any point on your circuit and this to any point on your circuit. They're both high impedance probes, 1 meg to 10 meg depending on the probe you got. And then you set your oscilloscope to see this waveform to ground reference mains, and this probe referencing ground as well through the chassis. And then you tell your scope in a math function, you say, well, subtract these two voltages and show the new waveform. And then that'll tell you not only the shape of that subtracted waveform, but its values. Now, this is very difficult to do, especially with a cheaper version of an oscilloscope like this little Tektronix I got, because in order for that math to work out, once you get the probes hooked up, you have to get both of those large voltage waveforms on your oscilloscope properly. And before you're going to be able to see that math function, you even have to get the math function wave, which would be the result of these two subtractions. You have to get that set right too. So you got to be really good with your scope in order to use this subtraction system, where you have to have a lot better scope than I've got. There are other ways you can do it without an isolation transformer. You can get what's called an isolation probe. It's an expensive probe, which actually isolates your circuit under test from the oscilloscope, and hence it can't reference ground. It'll have two connections on it, and it's essentially doing the isolation for you in the probe, and then it's going to then amplify that signal and reproduce it and send it to your scope. It's fully decoupled from the scope, so the scope can't ground out your circuit. That's expensive because those probes are expensive, plus you have to have active probe scopes. Your scope has to support active probes, or you have to buy an active probe that actually is powered by its own means and can have an amplification circuit and stuff within itself to use with a cheaper scope like mine, and those are even more expensive if you can find them. Or you could make one. You could probably make your own active, your self-powered active probe, isolation probe. But then you're still not getting away from that main problem, which is, yeah, your scope is safe now, but if you touch some part of that circuit accidentally and your feet are on the ground or you're grounded some other way, you're still in a dangerous environment there, and you could still get hurt very bad. And I've noted this before in previous blogs. Don't work on power supplies unless you're really comfortable with it, because you probably will do that once or twice. So if you can get your hands on a good isolation transformer, a tech version, or alter it into a tech version like I'm going to show how to do, then you can make that mistake and you're still safe. Now you can't cross across a transformer. If you touch 2 points of your circuit, even with an isolation transformer, you still make a complete loop and you're still going to hurt yourself. But then that's a lot rarer that you're going to do that than just accidentally touching 1 point and your feet are on the ground. That's a lot more common scenario for getting hurt. Now, you can get something for your oscilloscope. You can get what's called a ground monitor hooked up for your oscilloscope, or specifically buy a recommended isolation product for your oscilloscope that will also decouple that grounding reference for you safely. So there's that too. You can get a product like that. But then again, you still have the dangerous circuit you're working on, because your circuit would still be just as dangerous to you if you did that. And lastly, you got your power connector for your oscilloscope, and you've got this problem with the ground reference. You can defeat this, but don't do that, because then you got a real problem. Not only do you have a dangerous circuit on your hands, your scope can't reference ground anymore, and any high voltages that you happen to hook your scope up to, anything that you hook this up to, will then show up over here. And if you accidentally touch your scope, thinking your scope is safe, well, it's not, because if you defeat its ground to try and float that voltage, and you accidentally go hook up another probe, you're gonna touch 120 volts or whatever it happens to be there. So that's even more dangerous. So don't do that. Don't set yourself up for that. Just get yourself an isolation transformer instead. So the last really good point about an isolation transformer is it does have some cleans up the signal some. It removes spikes and it removes some noise, and so your circuit, your waves that you're looking at or you're testing throughout your circuit become cleaner to look at, because only a clean signal is getting injected into your circuit, and hence your scope won't be picking up any of that noise. So that's the last real good reason for having an isolation transformer on your bench. So just to make it simple on the diagram here, I'm showing an isolation transformer. It's essentially any transformer really. You have a primary P over here, this is this side, and then you have your secondary, that's S, and that's this side. Because it's a 1-for-1 transformer, the coils are exactly identical, and if you then have a load over here, the voltage of 120 volts here, because of transformer theory, will then show up on this side exactly the same, 1-for-1, 120 volts. But those, because of the way transformers work, spikes and like say if a motor turns on or off someplace in your building and the spike goes on the line, that is an instantaneous change that can't go across this transformer. So that's the decoupling that you normally want for a public isolation transformer. And then what happens over here is if you actually have ground over here, of course. We'll put a ground over here. This is your ground. Man, I'm terrible at drawing ground, ain't I? So this is a ground over here, and of course that's just the chassis, the third prong of your power coming into your isolation transformer, and it's strapped back to ground. And then on this side, it straps to your chassis, and that's pretty standard for anything. That's what your point of your third prong on your outlet is. That third prong is a safety ground, and it goes to ground and usually to the chassis or whatever you got. And in a tech version of an isolation transformer, if you measured the voltage, say from here to ground, if you measured this potential here, you would get 0 volts. Also, if you measured this to earth ground, you'd get 0 volts. And that's what you want, because if you or your equipment is connected to either side of this to this side of the isolation transformer and happens to hit one of those hot wires, it can't reference to earth ground and hurt your equipment or you. But that's a tech version. If you have a public version like a Tripp Lite isolation transformer, what they do is they actually have a strap, and we'll go ahead and put it in. They strap this secondary coil windings to the chassis. Now they do that for common mode noise rejection, so that the signals are cleaner for the equipment that is hooked up to this thing. And it's also an NEC requirement, so they kind of have to do it because this produces a second neutral for your secondary system, which is great for that opportunity, but it's really poor for you as a technician. Now, if I measured, if you do this, this becomes this essentially, because this point is the same as this chassis point over here, and that of course goes to ground. So now you have a ground referenced, a high voltage ground referenced environment on your secondary. So if I measure it over here now, this secondary would have 120 volts on it. And it's really there. It will actually, if you actually were standing over here and your feet got to ground, or any part of the chassis or any other ground point in your house, and you happen to touch this over here with your finger, then you essentially become a light bulb, or your equipment, because the current in the secondary will flow over through you to ground. It'll come across the chassis or the ground wire or ground. It'll come, if necessary, all the way over to your grounding of your house over here. It'll come up into the chassis and back up and complete that loop. And you have a perfect loop. So that's not safe for you as a technician. And it's not safe for your equipment. But that's okay, we're going to fix that. So here's a whiteboard schematic of setting up a dangerous circuit with your tech isolation transformer when using your oscilloscope. I covered this earlier, but this is just a little drawing so it hits home. So you've got an isolation transformer. It's not strapped to ground because it's a tech version. So when you measure voltage across this circuit, and you're not testing it, you don't have anything hooked up, even even if you have a circuit under test over here, you just haven't hooked up your scope. This is your oscilloscope. That's my idea of drawing of an oscilloscope with an oscilloscope probe. And you can measure the voltage on your secondary from either point, and you're going to get 0 volts, like I said earlier. But your scope has, unless there's some sort of monitoring going on or control, your scope has a ground reference. And that ground reference goes up to your BNC connector. Your BNC connector goes out to the probe. Okay? Once you take and hook up that BNC's ground shield to any part of that circuit, in this case I went high, I could have went low, it doesn't really matter. As soon as you do that, that's your new neutral of ground reference neutral for your secondary and your primary. For the secondary on your isolation transformer. And so any point on that your circuit under test is hooked up to, that's at the opposite side or any higher side voltage, is now set up as a high potential voltage environment. So this voltage down here, which was 0, as soon as you hook up that ground probe, I didn't hook up the actual test probe. It doesn't really matter because I'm just demonstrating you're strapping your secondary to ground. This goes to 120 volts right away. And it's really there. And at the very end of the video, for those who are visual learners, I'm going to go ahead and light a light bulb with this scenario. So you'll see just that you've set up a dangerous scenario with your tech version of an isolation transformer by just simply hooking up and testing. So if you actually touch this circuit and your feet were grounded, and or you touch some other ground on the secondary, you create a loop. It goes through ground or the chassis or whatever loop, however you create that loop, and you just created through your oscilloscope a current. Okay? All the way through that loop, through your oscilloscope. Now, current will flow in a loop at speed of light, so that's going to go real fast, and you're going to get zapped. And you might think, well, I'll just hook up a GFI to this output. Well, that's not going to help you at all. And I'll go ahead and try and cover that too. because this is all outside of that outlet of your isolation transformer. So this scenario, a GFI on your outlet of your isolation transformer wouldn't help you. And then one last thing is, it doesn't necessarily have to be you that's connecting this. You could do this with your oscilloscope, and I'll demonstrate at the end too. I'll have a little video. You could take a second oscilloscope, which has a second grounding strap, and if you decide to take that probe down here and hook it up here, well, then you've also created that full loop. You've also created a current through your oscilloscope. So if you're going to use a two-probe system, then make sure that that clip goes to the same exact point. If you use a second oscilloscope, make sure they go to that same point like that, so that you don't set up that loop through your oscilloscope and damage your oscilloscope in that way too. Okay, real quick show of the product. I have the Tripp Lite hospital grade 1000, because it's a 1000 watt product. Has a really nice big on-off switch. I like that. It's got a circuit breaker. If you go over the, well, they rate it at 8.3 amps, but this breaker is actually going to go up to 9 amps for that. It's heavy, 40 pounds. I need a lot of amperage. The mine's big. I don't recommend you necessarily get a big one like this for your bench, but it's got the output on the back. This is isolated. Right now it's referencing ground, but we're going to alter it so it doesn't reference ground. So it'll be safe to plug in our test gear here, or in our circuit under test, and use our test gear and ourselves on it just fine. Has a grounding wing nut here for in case you want to ground your cart or something to it. And that's about all there is to a transformer. Now they make different grades. These publicly available non-tech version Tripp Lite transformers, they make them in grades, and I'll show a little whiteboard of that in a second, of the different sizes. This one's pretty big. I know that I'm testing some motors and stuff, so I know I need to go over 6 amps. So I did order the more expensive one. I only got hospital grade because it was cheaper at Amazon. If I wanted to buy the non-hospital grade, it would have cost me more in shipping, I suppose, because it's so heavy. At Amazon, it was free shipping. But it was rated the same as the non-hospital grade one, so it doesn't really matter there. But for a regular tech bench, I would say that if I wasn't working on a motor that I knew was drawing 6.5 amps, I would probably have went with like a 4 amp version, which would have been, it would have been a lot smaller on the bench, a lot lighter. Would have done the same thing. It's not likely you're going to have too many things you're going to test over 4 amps, really. And if you do, you've got the breaker that you can just reset. So kind of decide if you need more amperage, get more amperage. They go all the way up to like 15 amps, but you know, that's like $700 product, and it would weigh 55 pounds or more. And then there's even smaller one you might want to consider, like I think there's like a 2 amp one, which would really be, if you're just doing some really low amperage bench testing with mains power, that's probably decent enough for most tests. Okay, now there are different sizes, like I said. There's also different grades. I happen to get the Tripp Lite. Let me see if you can see this better. I've got the Tripp Lite IS1000. 1000 is because it's 1000 watts, or essentially that comes out to 8.8 amps at the voltages we're doing. And I paid $314. Now, that seems like a lot of money just for something that's to isolate you from the mains, but it's going to protect you, and your life is worth it, and it's going to protect your equipment, which is definitely worth it. And because this is a hospital grade HG, it's going to have a lot more. It's going to have a little bit more protection than your non-hospital grade versions, and it's going to have more noise filtering. So your scope is going to be much easier to use, much cleaner to use. And I think this one here is just a 2 outlet, like this small one is just a 2 outlet, whereas this one I got, these larger ones are 4 outlet. This one's a 6 outlet. Okay, I'm going to show a real quick test. I have my isolation transformer plugged in. It's not altered. It still has the secondary coils strapped to ground the way it's shipped from the factory, which is the way it is for a public isolation transformer. I'll go ahead and I got to take a light bulb to show that it's a working transformer. It's got an adapter to an outlet. Get the polarity right, plug that in, turn my transformer on, and the light bulb lights. Yay, it works. But more importantly, I'm going to show another test. And that next test is a voltage test. Of course, if I take my voltmeter and I change it, I got the Fluke 117 electrician's voltmeter or electrician's meter. I got it set to volts AC. I'll stick it into the socket here and then turn it on. I'll go ahead and turn it on right now. I'll put the red into the smaller slot, which is always the hot side. It's smaller, so it's harder to get something in there, is the way I think of it. And then I'll put the black in the common. And then across there we see, of course, there's 124 volts. More interestingly, though, is I have that same voltage if I leave this red in this hot side of this isolation transformer's output, and I come over here and I measure to ground over here. This is just the chassis ground of my outlet. You can see that 120 volts still shows up on the meter if you're looking at the meter. That's not good for a tech bench because that's a high voltage, and it's really there. I'm going to show it's there by just lighting a light bulb real quick. And my test that voltage is actually able to provide a current. It's not just a high voltage with an infinite resistance. Is I got my light bulb with one leg hooked up to the hot side of an outlet cord, a little short outlet cord. I don't have the other two sides. I don't have the second leg, the white or the ground, hooked up. And what I'm going to do is I'm going to go ahead and plug that into my transformer. It's still an unaltered transformer, factory transformer with that strap, secondary strap to ground for common noise rejection. I'm going to hook up the clip of this little alligator clip to the other side, and then I'm going to touch it on the grounding point over here, the same grounding point. I'm just going to touch it to this case over here. So I'll set the light bulb there. And you can see I'm about to touch over there. I'll go ahead and turn on my transformer. So this is going to become a hot circuit. And because that secondary is strapped to ground, that light bulb still lights. And that would be really bad for you or your test gear because if you become a fault to ground, regular earth ground, then you're going to light up just like that light bulb did. But we're going to show it that we can fix that. Okay, now for the fun part. We'll take it apart. There we go. Look at that. Oh my jeepers. Have you ever seen such a transformer? Oh, look at the size of that thing. Jeez, this is my hand. It's as big as my hand. There, we got this apart now, and we're going to go ahead and take a fly through on the circuit a little bit. This is the large transformer. These are the outputs from the secondary, and then of course the input on this side, and cable comes in here. Power comes up to this switch out front, so you can break the power on and off. Then it delivers the power down to this 9 amp breaker in case you go over amperage. There's no wires. They seem to come up and they go into the primary part of the transformer. They come out over here at the secondary. These are going to be really well beefy designed copper in here so that you get a real good performance across this transformer. They'll go through the problem of making sure that's done. There's going to be a Faraday cage in there so that there's less chance of any arcing across the transformer's primary and secondary, so it's a little bit beefier than that. If I can zoom in on that right there, essentially that is a temperature overload. If this thing gets too hot, it's gonna cut the circuit there with the temperature sensor down in there. And let's see, oops.
And let's see, then we come down to the transformer being fairly well mounted with these essentially locking washers. They use locking washers everywhere, even this big old stack of grounding lugs there, they're all locker washed individually. So they make real good use of that. They're not going to let any vibrations of this transformer take this thing apart. They got really good strapping. They've wrapped everything up real good. Nothing really shoddy with the wiring. I would say I don't care for this right here. This is on essentially the hot side, of course. And there's most of all of these insulating crimps are fully insulated. But this one back here is not fully insulated. You're not supposed to be in here poking around, but if you were, that would be nicer if both of those were fully insulated, in my opinion. Minor thing, no big deal. And then let's see, over here we have, well, I guess we're going to consider this some sort of a cleaning up. This is it says revision 2 hospital grade board. See if I can zoom in on that. It's got the hot and the common coming into it. It's not populated with a lot of stuff. You can see there's lots of, looks like adjustable resistors with lots of voltage points referenced, but it's not populated. The only thing I really see on that board is a couple of mains caps, a couple big ones and then a small one, and that's about it. And the primary connects on this side, and the secondary, if you can see back over there, the secondary is also connected in the back side, way back there. And then the grounding, of course, comes from that grounding strap, comes up and goes into a 3-prong grounding for your outputs here and here. And this is the bit that we're going to have to change. This is common here, of course, and there's 2 of them because they're strapping these 2 together, and that's the common for the secondary transformer coils. And you can see this red one here. It's actually connected directly into that secondary coils right there, and that straps to ground, and that's what's going to cause that problem that we don't want as a technician. Fine, they have to do that for NEC. They want that for the equipment and for the hospitals and for computers and so forth, but we don't want that for a tech version of an isolation transformer, so we'll be taking that off. They also have, these are some interesting outlets. They have essentially snap over covers that cover these connectors. I guess because maybe this is hospital grade, they've got they want to make sure that nothing can accidentally come in contact between anything that the patient might be hooked up to or any other thing. So they got these snap covers, which are really interesting. I haven't seen those before, and that must be what this little green dot back here must mean, that they're going to have that extra strapping on it. On the back is the 4 outlets. Like I say, the smaller units have 2, the larger units have 6. So the 15 amp one has 6 of these, but I mean, I think 4 is too many for me. It's got the ratings. This is the hospital grade IS1000 HG. Just tells you the input and output. Let's see, over here they got this transformer labeled 120 volts AC in, IS1000 HG, and then its output is 123 volts AC. So they've got that labeled nicely. It's got a lot of varnish on it. It's not too messy. I don't think it doesn't vibrate much. I've had it on. It doesn't make much noise at all. So, well, I mean, as long as they're put together well, that's about all there is in a transformer. It's there and it'll do its job. And we've made that alteration to our transformer. We'll zoom in on this. Okay. This is that strap from the secondary that goes down to the common connect on this outlet and straps the secondary transformer windings to common, essentially straps it to ground. I've taken that ground strap off, and rather than actually trying to get in there and take those protective shields off and try and unscrew that, I just left it connected there and unhooked it from up here at the terminal posts where these grounding 3-prong grounding grounding wires connect. I left them, of course. I only took off this one going to the secondary transformer coils. I put 2 layers of strap over it, and I'm just gonna just leave it in there, and it'll essentially be a a nice safe to do that. And now I don't have the common mode ground noise rejection between the two. I don't have that common signal being canceled out anymore. I don't have a secondary neutral, but what I do have is a transformer that I can use as a tech bench isolation transformer, isolating me from those possibilities of short circuits and my equipment. Our transformer's back together. It's now a tech version of an isolation transformer. We have our light bulb hooked up again with just that single leg hooked up. The other leg is hooked up to this little alligator clip. We're going to show that we no longer have that potential voltage, that dangerous voltage with current to ground anymore. So we'll turn on the transformer's on. I'll reach over here and I will touch the grounding, essentially at any point that's ground. This is essentially the ground point of my house, and nothing, light bulb isn't light. And that's good, right? Now I guess got just a regular light bulb again with the socket. I'll go ahead and stick that in just to show that the transformer is fully functioning transformer even without that, even with this alteration. Turn it on, light bulb lights, just perfectly functioning transformer. Now to show the voltages, I've got my my red of my fluke hooked into the hot side. I'm going to hook into the neutral side. Turn on my transformer, and we get 124 volts AC across that transformer. Still, with the alteration, I'm going to go over here, and this gets interesting. I'm going to go ahead and touch the ground again over here with the fluke, and you can see, you still see voltage. That's ghost voltage. It's being picked up across the lines. Essentially, it's a capacitance thing. We no longer have that strap going to ground for the secondary transformer, and so we're gonna pick up some voltage values, but they're not dangerous. And to prove it, we have a 117 fluke electrician's meter, which actually has what's called a low Z, a low auto Z, which will measure the voltage without those ghost voltages. And electricians need it to test stuff, and I need it to test a transformer. And you can see it's reading 0.1 volts as actual volts that's there. So that ghost voltage isn't really there, and it's not going to be a problem for an oscilloscope either. And the last test to show the proof in the pudding here is I got the same little pigtail, but now I got two shielded connectors, and I'm going to hook my oscilloscope up to it. I'm going to do it front ways and back ways to show that neither way will hurt my oscilloscope. So I'll go ahead and plug that in to my isolation transformer, my tech bench isolation transformer. I'll go ahead and show the normal way you would hook this up first, which is you would connect to the common, to the ground. That would normally not be a problem anyway, but you got to make darn sure that's what you're doing if you don't have an isolation transformer. And then I'll hook the probe, the high impedance probe, up to, which is just a standard 10 meg probe, to the black, the hot wire. And I'll turn on my oscilloscope and my transformer. And there we see nicely a 60 hertz, 120 volt RMS. You could even actually probably labels it in there. On this little bit, it's perfectly happy. Hit auto. Whoops, let me hit auto on that once. Auto will throw up some more measurements, I think. Yeah, if I hit auto, it actually does a little work for me. It throws up the RMS value, 127 volts RMS, 60 cycles, peak to peak, 350 volts period. So it's, you know, some people don't like the auto feature on a scope, but I'm okay with it. I can use a scope either way. So now we're going to switch these. What you wouldn't do without an isolation transformer is I'm going to go ahead and hook this ground clip of my probe up to the hot leg, and this would be disastrous normally, but not with an isolation transformer properly altered. And I'll hook up to the ground, and then you'll see the waveform jumps right back. And nothing went bang, nothing melted, everything's just fine. Let's see what the noise looks like on one of those lines. I'll hook up to that and hit auto. See what it picks up. Let's see, we're getting that noise on there. We're getting 19.4 volts on the common, 60 cycle. That's what would be taken out for sure if you hadn't altered your transformer. But that's not important when you're actually using both probes on your circuit. That's not an issue. And we'll go ahead and we'll probe the hot, just the hot, and we'll hit auto again. Auto set, see what it finds on there. And now we see 92 volts. And essentially that's because you got, I'm not hooking up this, oops, let me unzoom. That's all happening because I'm not hooking up this ground probe to anything. I'm just hooking up the high impedance side. And so it's actually measuring what it sees over at the chassis over here. It's measuring between chassis and the probe tip, and you've got all this in between. But if you hook this directly up to your circuit at the same time, then that all goes away. I'm gonna hit auto over here. Dave Jones would be mad at me, wouldn't he? And so it just comes right back real nice to that 100, actual true voltage that's there when you hook up your probe tips properly with as short a lead as possible on your grounding clip. Okay, I want to make this this demonstration for sure. I want to make sure everyone sees this, and that is how when you're using an oscilloscope. Once you hook up your oscilloscope, once you hook this up, like I've said earlier in the video, you make this point the neutral reference point of your secondary on your transformer. And I want to show how once you do that, your circuit's dangerous again to you. You can ground yourself again, and or you can ground a second probe. And so I'll show that. So first, we have over here the transformer. We have my little outlet plug pigtail here. You got two. You got a hot. You got your neutral and your essentially your two sides of your transformer. You got a circuit you want to be under test. So this is an Xbox circuit. You're gonna set that over here. You plug it in. It's not working. There's something wrong with it, but it's plugged in, and you want to start probing. Okay. But when you start probing, you make your circuit dangerous again, and we'll just demonstrate that with the light bulb again. I'll take this out of this picture because it's not working, and we don't want to confuse the demonstration with that. But you can just imagine that's still hooked up. So if I then say that I'm not probing right now, but you're a light bulb, you're the light bulb, and you connect yourself up to one side of your circuit by accident. You're touching something you shouldn't be touching. Okay, it doesn't matter which leg I hook that up to on the transformer. Now, this green strap, like before, represents your feet on the ground or some other ground point. And you're the light bulb, so your light bulb's got feet, and it's going to touch something it shouldn't be touching on the circuit and to ground. Now, I'll turn on the transformer, and the same demonstration as earlier. Nothing happens when I go to ground over here on my outlet, which is grounded, earth mains ground. The light bulb doesn't light. You don't shock yourself because that's the point of isolation transformer. You're making it safer. But got my oscilloscope here. I'm going to go ahead and I'm going to hook up my oscilloscope. I'm going to hook up to some point on my circuit. I'm just going to call this common for now. That now becomes the new neutral reference for my circuit. Like I said, it doesn't matter where I hooked it up, that becomes that. And I'm probing, of course. This doesn't matter. Probing, actually putting the high impedance probe on doesn't really cause the problem. I'm just going to do it for demonstration purposes. I hook up the probe. I think everything's safe, but it's not. My isolation transformer is not making the circuit safe no more because this ground strap on the oscilloscope is going to earth mains ground, just like your feet or anything else. And so the scope is working. Everything's fine. Now, I haven't changed anything with my circuit over here. You're still the light bulb, and this is still your feet or some part of your body that's touching ground. All I've done is hooked up the oscilloscope. Now I'm going to go over here and accidentally touch ground. Boom! You just lit up like a light bulb. So that's what you got to be safe about when you're using an isolation transformer. Make sure you're not setting yourself up for that. You got to keep your head in the game. It's only giving you a level of protection, not perfect protection of any kind. Never go there. Likewise, if I have a second probe, If I hook this second probe directly up to this test point that this first ground point is, that's fine because they're the same neutral point. But if I made a mistake and wanted to, say, test some other point in my circuit, and I hook this up to some other part of my circuit, well, now I'm going to ground the transformer, the secondary of the transformer, through my oscilloscope. And, well, that's going to destroy your oscilloscope just as if you had done it with mains. It doesn't really matter. So be careful, be safe, really understand what you're doing here when you're using high power mains with your circuit under test. Well, that's my my look at the isolation transformer for a tech bench and how you can get yourself one and make sure you test and understand how it's working for you so that you can be safe working with high voltage mains on your circuit under test. So get one of these. If you're going to do that type of work, make sure it's working for you, make sure you test it, and be safe with it. Thanks for joining. See ya.